Welcome back! In this video, we'll be talking about percent error. Percent error in chemistry is a method to compare an experimentally derived value to the actual value that should have been observed. In other words, you're comparing the results you got in your experiment to what you should have recorded in the experiment. So it's a measure of accuracy. For example, if you're trying to derive the density of gold in an experiment and you get 19.5 grams per centimeters cubed, that would be your experimental value. However, the actual density of gold that you should have observed, which is 19.32 grams per centimeters cubed, would be called your accepted value. Again, percentage error is a measure of accuracy, and a higher percentage error generally indicates that there were larger sources of error throughout your experiment. The experimental value is the value you observe in the experiment, and the accepted value is what you should have observed. The formula for percent error is simply the absolute value of the experimental value subtracted from the accepted value. And then you divide this quantity by the accepted value, and lastly, you must also multiply this by 100 in order to get your percentage. If you don't multiply by 100, you would only get the decimal error, not the percentage error. Lastly, you want to make sure your answer has the same number of sig figs as the number with the least sig figs in your equation. Let's do another example. Let's say that 14.1 milliliters of water was measured when in reality it should have been 13.8 milliliters. 14.1 milliliters is the measured or experimental value, while the accepted value is 13.8 milliliters. Plugging this into our percent error equation, we get the absolute value of 14.1 minus 13.8 divided by 13.8, which gives us 0.021739. Now, you must multiply this decimal value by 100 to get the percentage, which is 2.1739. Finally, according to our sig fig rules, 14.1 and 13.8 both have 3 sig figs, which is the least number of sig figs in this equation. Thus, our answer must also have 3 sig figs. We can then truncate the decimal and get a final percent error of 2.17%.